Hey guys, welcome back to AlgoYogi. We are doing array and hashing series, and our next problem in the list is number of good pairs. If you haven't done divide array into equal pairs, please check that out because this problem takes some inspiration from this one. So if you have done this one, then try it yourself. If you can't, then please continue the video. So let's go to LeetCode. All right. Given an array of integers nums, return the number of good pairs. A pair I and j is called good if those two numbers are equal at I and j indexes and I is less than j. So they are not equal. The indexes are not equal. So you can't make a pair of a number by itself. All right. So I've taken the first example right here. We are given nums and we need to basically count the number of good pairs. What is the definition of good pair? So we need to create good pairs or count good pairs where basically a pair I and j, I is less than j and nums at I is equals to nums at j. So tell me the brute force solution of this problem. What would be the brute force solution for this problem? Well, I think since it's about finding this pair, how about for brute force, I would basically iterate over this, twice for each element. So I'll have for I in range this nums, and then for j in range, you will start at I plus 1 because you don't want to include I and go until the length of nums. Okay, I'm writing it in this way. And then you basically check if those two numbers are equal. If those two numbers are equal, so this condition you will check and then you will increment your, let's say, count. So count good pair. Let's say this, you will keep incrementing. This condition will come over here. Keep incrementing this and then finally you will return. So this solution is of time complexity big of n square. All right, big of n square, and space is basically constant. Can we do better? Yes, we can definitely do better. We want to do single iteration, so basically bringing down this time complexity to big of n, but that will involve some introduction of some space complexity. So let's move to a more optimized approach where we will bring down the time complexity to big of n and we will introduce some space complexity of n. So the idea is simple. Since we are going to create pairs and that of equal values, so how about I just count the equal values? So let's say in my array, how many ones do I have? So 1, then I have this one, and then I have this one. So the reason I'm drawing them in different color is that because they have different indexes. So how many? So let's say in order to create pair out of this one, first they have to be equal, which I have chosen. I've chosen all these ones. I have extracted them out. Okay, I have extracted these ones out. Now in order to create a pair, I will choose, let's say, this one, the green one. Then at this place, how many values can I have? Well, I can have two values. These two values I can have. Okay, these two values can take this place. So what's really happening is for all these pairs, all these values, if the count is, let's say, 3, then for the second one I could have two values. So this means I can create 6 pairs. But I'm trying to find the permutations, right? We are doing some little math here. So, but can we really create 6 pairs here? If you see, how many pair can we create? So 1 and this one. Okay, that's one pair. Then green one and then red one. Okay, then I'm gonna have this purple one and then this one. So this these are only 3 pairs that I can create, right? I can only create 3 pairs, only 3 pairs, but this math says I can create 6 pairs, which is wrong, but we will see why this is wrong. The reason is, what it has done, this permutation has done is, it has also counted the flip, basically this version of these pairs as well, this version, okay, this version as well. So what we'll do is we will divide this by 2. So by the way, this is not allowed. This is not allowed. Why? Because we have been asked that I has to be greater than j. Okay, we have been asked that I has to be greater than, sorry, less than j. All right, so that is why this cannot be counted. So what happened is we have counted twice as many pairs as we were supposed to count. So that is why we will have this value divided by 2, which will give me 3, and that's the number of pair that I will add to my final answer. Okay, so 3. So 3 good pair with 1s, then 2 doesn't have any matching pair, then 3 will give me 1 more pair. Well, this 2 has the count 0. This 2 has the count 0. Then so this will be 0, 0 minus 1 divided by 2. This will give you 0. So you cannot create any number of pairs. So that is why first what we'll do is we will use a hash map to count the frequency of each number, right? Frequency of each number. Let's just code our solution. It's a simple one. So the first one was using 2 nested for loops. For each I, you find a j, and then once you find it, you increment your count of good pairs. So count good pair. Then let's have count good pairs is 0 right now. Let's have count the nums. So num count, I would say num frequency would be I'm gonna use the inbuilt counter, which is just counter in Python. Now let's go through all the key and value in the num frequency. Okay, dot items. Now what I'll do is let's get the good pair count. So I'll just say count would be, for this value, what I'll do is val into val minus 1. So val minus 1, and this everything will be divided by 2, and then I will add this count to my num frequency. Okay, so num frequency plus this. And since we are just adding the pair, so we could just have the absolute division by 2 here, right? So this will be the final, sorry, not num frequency, the good pair count is what we are adding finally, and that's what we will return. And let me zoom out and let's see if this works. So I'm gonna run it on the examples, and great. So you can write brute force or this one, they're all equally good. I think the brute force is not equally good, sorry, my bad. It's just here we have introduced, we have brought down the time complexity. We have brought down the time complexity to big of n from n square of the brute force solution. But brute force solution where you use 2 nested for loops, and then for each I you find a j where the numbers are equal, and then you increment your good pair count. That one was using constant space complexity, but this one is using big of n space complexity because of this the counter, where you can say it m, or where there are I can say it like, let's say m means unique number of elements. Okay, so let's go back to AlgoYogi, mark this problem solved. See you guys later in the next problem. Until then,